We may not live in a Pokemon world, but we do live in a particle world. Philosophers in ancient India and ancient Greece supposed everything in nature must be made of indivisible units, distinct pieces from which the universe constructs, well, itself. Particle physicists like me continue asking these kinds of questions. What is all this stuff? What does it do? Why is it like this? In other words, who's that particle? And how does it interact with others? Since discovering electrons and photons in the 1800s, we've had quite the journey, filling out the Pokédex entries for all the basic building blocks of matter, the stuff you, me, and the stars are made of. In the 1960s, researchers used the SLAC Linear Accelerator here at SLAC to slam electrons into protons and neutrons, revealing that protons and neutrons were made of even smaller particles called quarks. It was a bit like learning surf in a Pokemon game. This discovery opened up whole new areas of exploration. We now know matter comes in three types: quarks, leptons, like the electron, and force carriers, like the photon. The force carriers ferry messages between particles using the electromagnetic, strong, and weak forces. We call the Pokédex of all these facts we've collected the standard model of particle physics. In 2012, we caught the last particle of the standard model, the Higgs boson, in the tall grass of proton collisions created by the Large Hadron Collider, or LHC, and detected with experiments ATLAS and CMS at CERN. Now, the standard model is the most successful theory we've ever developed. But analyzing Planck's satellite data reveals that the standard model Pokédex accounts for only 5% of the universe's total energy. And there's no gravitational force in the standard model Pokédex at all. So we're upgrading the LHC to smash more particles together than ever before, so we can chase those elusive, legendary particles like dark matter. Just like swapping your running shoes for a bike, the LHC upgrade allows us to cover more ground faster. At SLAC, I'm leveling up ATLAS with the new tracking detector to keep up with all those collisions, because we've got to catch them all.